Hello everyone, welcome back to my YouTube channel. Today we are discussing another problem from the blind 75 list of problems, and the question is named product of array except self. In this problem we are supposed to return an array from the input array such that the answer I in the resultant array is equal to the product of all elements in the array except nums of I. So for example, if we are given this array 1, 2, 3, 4, I am supposed to return another array of size 4, and the number on the first place will be product of all these numbers except 1. So 2 into 3 into 4, that will be 24. 24 will come here. Similarly, if I exclude this, so 3 into 4, 12 into 1, 12. And similarly for the third place, it will be 8. And for the fourth place, exclude 4, so 3 into 2 into 1, which will be 6. And similarly for the second array, this product will be 0, 0, and 3. Sorry, this is also supposed to be 3. So 3 into 3, 9, and minus. So this will be 9 and 0, 0. Everything is 0 except the middle one because the middle element is 0. Now let's see what else given in the question. We are given that the product of any prefix or suffix of nums is guaranteed to fit in 32 bits. And we must write an algorithm that runs in O of n time. And we must not use the division operator. So if we had the division operator, we would just multiply the whole array and multiply all these numbers, and for each place just divide it by the number at that place. So for example, the product of this would be 12 to 24, and I would just keep on dividing 24 with the number at that place. So 24 by 1, 24, 24 by 2, 12, 24 by 3, 8, 24 by 4, 6. So we can't directly do that because it is given that we can't use the division operator. And the length of the array is 10 to the power 5. Each number is less than 30, and this is the same thing. The product is guaranteed to fit in 32-bit, and we are also given a follow-up that we solve this in O of 1 extra space time complexity, and the output array does not count as extra space for space complexity. Now the first thing we'll notice is that for constructing the answer, what we require is, so for example, I want the answer at second index. So for this space, what I would need is the product of the numbers in the array before this and the product of the numbers in the array after this. Okay, and to calculate this, I can't run a loop for every number behind this index and after this index because we are supposed to solve this in O of n time. So is there any pre-computation that we can do that helps us finding the product of numbers before this index in O of 1 time and after this index in O of 1 time? Yes, so what we can do is create a prefix and suffix array. So let's say this is prefix array and we have another array called suffix array. That will also be of the same size. And what we can do is store the product of the numbers before a particular index in the prefix array and after that particular number in the suffix array. So what we do is, for 1, just store 1 here because there are no numbers on the left of 1. And for 2, what I do is just multiply what number is here with the number in this one. So it will be 1 again. And when I move here in the third place, what I do is multiply this with this. So 2, and same for the third index, it will be 3 into 2, 6. So now at each place I know what is the product of numbers on the left side of that index. So for 4, it is 3 into 2 into 1, 6, which is stored here. For 3, it is 2 into 1, which is stored here. And for 2, it is just 1, which is stored here. And similarly for suffix, instead of moving from left to right, I just move from right to left now. So let me just clear the board a bit. Okay. This is the prefix array we constructed. Now for the suffix array, I'll have 1 in the rightmost place because there are no numbers on the right of 4. So there's no sense in having any other number there. And for the second index, I'll just multiply 4 and 1. So this will be 4. For the first index, I'll multiply. So for the second index, I multiplied 4 and 1 and placed it in the second index. Now I'll multiply 3 and 4 and place it here. And similarly, I'll multiply 2 and this and place it here. So let's fill that real quick. So 4 into 3, 12. Let's place 12 here and 12 into 2, 24. Okay. So let's check if it is correct. So product of numbers on the right of 4 is 1. Product of numbers on the right of 3 is only 4, so it is correct. Product of numbers on the right of 2, 4 into 3, 12, which is correct. Product of numbers on the right of 1, 3 into 2 into 4, which is 24. Now to construct the resultant array, remember what we discussed earlier? We just need the product of numbers on the left and the right. So we directly use these two pre-computed arrays and just get the numbers. So product of numbers on the left of 1 multiplied by the product of numbers on the right of 1. This we stored here and this we stored here. So we just multiply the indexes and prefix and suffix to construct the resultant array. So 24, 1 into 12, 12, 4 into 2, 8 and 6, which is our expected output. This is our result. Now let's see how we'll code this out. And before doing that, let's just also calculate the time and space complexity for this. So time complexity will be O of n. So constructing this is O of n, constructing this is O of n, and at the end calculating rest is also O of n. And the space complexity is also O of n because we are using two additional arrays in addition to the resultant array. Now we are given an input array nums, and what we discussed is creating two arrays, prefix and suffix arrays, to calculate our resultant array. So let's quickly create these vectors. So let's first of all name n as nums.size. We create prefix array which will be of size n and initialize it to 1. Remember we had to store 1 at the first place, so this will automatically do that. Instead of initializing it with 0, we can just do this. And let's create all three arrays at once. So press n, and this can be 0, so let's leave it. Now let's create the prefix array. So I'll start from the first place, go to the last, and what did we discuss? How we will calculate the prefix at any index. We'll multiply the previous index with the previous value. So 3 of I minus 1 into nums of I minus 1. Okay, then just recheck it. So for 1, 2, 3, 4, I'm at this position, so I need 1 into 1. For this position, I need 1 into 2. So that's correct. Now let's construct the suffix array for int I equals to n minus 2, I greater than equal to 0, I minus minus. This would be sub I equals to sub I plus 1 star nums I plus 1. Same as the above, just move forward instead of backward now. And in the end, to construct the resultant array, just multiply both of these. So rest of I will be 3 of I into sub of I. And at the end, just return the resultant array. Now let's see if this works. So both the cases passed, 1, 2, 3, 4 and -1, 1, 0, -3. Now let's try submitting it. So as you can see, it worked. Now let's see how we can improve this solution to avoid using these two extra vectors as is given in the description of the question. This is the follow-up that we can solve the problem in O of 1 extra space complexity, and the extra space doesn't include the output array. Now what we want to do is remove the usage of prefix and suffix arrays and use only res array to calculate this whole thing. Now one thing we can do is to avoid the uses of one of these two arrays is just use the res array to store one of these initially. So let's say I store the prefix in this res array only initially, and for suffix what I can do is use a variable instead of an array to calculate it on the fly where I calculate the answer. So for prefix I'll replace it with res. So I'll remove this and use res to calculate the prefix initially. And once I have the prefix array, I'll calculate the suffix on the fly in a variable and iterate this and keep on multiplying numbers in this array with this variable to calculate the final answer. So let's see how we will do it with this example. So for example, we have 1, 2, 3, 4 and I take a new array res which I calculate the prefix as we did previously. So as we calculated this array 1, 1, 2, 6, I use the same way to calculate this 1, 1, 2, 6. And for suffix, what I do is initially make this suffix variable 4, because what we want to do is at this place I want to multiply the prefix with the suffix. This 6 will remain the same because it doesn't have any suffix. So this will be the final answer in this place. I'll start from this place. So for this place, what will be the answer? The product of the numbers on the left side multiplied by product numbers on the right side. So left side the product is 2 and the right side the product is 4, which we just stored in this variable. So I will do res I multiplied by suffix prod. So 2 into 4, I'll make this 8. Now this is the answer. What I'll do is I'll update this suffix prod to multiply it with nums of I, which is the input array. So 4, I'll multiply by 3. So that will become 12. Now suffix prod is 12. So when I move to the next stage, what I'll do is multiply the prefix product with the suffix product, which is 12. So 1 into 12, this one will be multiplied with 12. So that will be 12. And at the first place, what I'll do is multiply again the prefix with the suffix. So 1 with suffix, this will get updated to 12 into 2, which is nums I. So 12 into 2, it will become 24. And once it becomes 24, I'll multiply it with the prefix product, which is 24, and I'll store 24 here. So I constructed this res array only by using one single extra array for the result and one variable, which is suffix prod. Now let's see how we will implement this in code. Now for code, what we will do is remove these two prefix suffix arrays, and in this I'll just store the prefix sum. So I'm creating the prefix product in this res resultant array, and after that what I want to do is create a suffix prod variable. So let's call it suff prod, which will initially be equal to last number in the input array. And I'll just loop over this resultant array. So n minus 2 and I greater than equal to 0 and I minus minus. So I start from the second last place, and resultant I will become resultant I star. What did we discuss? Star suffix prod. So the variable which we took. And after this step, we just update this variable to multiply it with nums I. Okay, and change this to n minus 1, and here we can use this shorthand notation to multiply. Yes, so let's try it out. Okay, something is wrong. Let me just check real quick. So n minus 2 I greater than equal to 0, I minus minus, resultant I am multiplying with this subprod variable, and this variable I am multiplying with nums I. What can be wrong? Oh, so in the prefix, I'm not storing the 0th digit. So at the 0th place, let's name it 1. Or what we can do is similar to what we were doing previously, we can just make this 1 fully before we calculate this. But I think that would be faster in this case. So let's try now. Okay, so now it worked, both the cases. Let's try submitting. So this worked as well. I hope you got it. If you didn't, feel free to leave a comment down below and I'll try to answer all your queries. Do like, share and subscribe this video. Till then, happy coding.